Hi friends, welcome back. Today we'll try to understand what is a minimal spanning tree, the real life application area of minimal spanning tree, and the algorithm involved to find out the minimal spanning tree to any given network. These are some of the application area of the minimal spanning tree. A minimal spanning tree can be used in laying of water and gas and water pipelines, laying of optical fiber, laying of electrical connection, etc. Such problem can always be represented in the form of network of edges and vertices, and the main objective of the minimal spanning tree is to connect all these vertices of the network so as to form a tree in such a way that the total span of the tree is minimized. A tree is a connected graph with no circle. This is what we have learned up to now. Now let's see the let us take this example. This is an example of a network consisting of 9 nodes. The numbers over here are the distances between the nodes. Now we can also assume these 9 vertices to be the 9 different locations, and we have the tasks of laying the water pipelines to connect all these vertices. Now, if you use minimal spanning tree to let down the water pipeline to connect all these vertices, then the length of the pipelines now for connecting all these points will be at the minimum. Now let's try to understand the algorithm. A minimal spanning tree can be solved using Kruskal algorithm. These are the steps involved in the algorithm. The first step of the algorithm is to sort all the edges, all the connections in the network in ascending order of magnitude, in non-decreasing order of their weights. Weights are the connections, the distance. Start constructing a minimal spanning tree by selecting the smallest by selecting the smallest connection, smallest the connection with the smallest weight, the connection with the smallest weight. At every step, a care should be taken while forming the tree. The tree should have no circle. Include only those edges in a minimal spanning tree which do not form a circle, else discard it. Repeat this process till the time all the vertices are included in the minimal spanning tree. The number of edges, the number of connections in the minimal spanning tree should be one less the total number of vertices in the graph. So for our example, we had a total of 9 vertices. So we should have a total of 9 minus 1 connections, meaning edges. So this is the arrangement of the weights of the given example. Uh, the minimum weight is occurring at in the connections 2 to 3 and 5 to 6 and 4 to 7. Similarly, the other weights are given over here and the connections are in this form from to 2. Now we select the first connection from the table because the first connection is having the least value of the distance weight. So this connection 2 and 3 are connected like this, and this is the first connection of the minimal spanning tree. Now next in the table is 5 to 6. 5 to 6 also is connected like this. Now we have 2 branches of the tree. Check for the circle formations whenever every time when you introduce new edge to the minimal spanning tree. Next in the connection is 4 7. 4 7 is also connected. 4 7 is over here. Next in the connection is 3 4. 3 4 also is connected. Then next in the table is 4 6. 4 6 also is connected. Circle formation has to be checked all the time. Then 1 4 also is connected. 1 4 is here. 1 4 is connected. Now you have how many branches in the tree? 1 2 3 4 5 6. These are the total number of edges in the current tree. The total number of edges in the current tree are 1 2 3 4, 5, 6. Now next in the list is 1, 2. 1, 2 is where? 1, 2 is this. 1, 2 cannot be connected because if you connect 1, 2, a cycle will be formed over here. Formation of circle in the tree is not allowed. So 1, 2 has to be avoided. 1, 2 has to be avoided. If you avoid 1, 2, what is the next connection? 5, 8. So 5, 8 can be considered. 5, 8 is over here. 5, 8 is connected now. Now after 5, 8 we have 1, 3. 1, 3, check 1, 3. 1, 3 cannot be connected because you will form a circle. And what next? 2, 6, where is 2, 6? 2, 6 also cannot be connected because you are going to form a circle with this connection. Then you have 6, 8. 6, 8 is where? 6, 8 is this side. 6, 8 also will form a circle. 6, 8 also cannot be considered. 2, 5. 2, 5 is what? 2, 5 is one. This one. Yeah. 2, 5 also cannot be considered because you are going to form a closed cycle over here. Then what else? 3, 6. 3, 6 is which one? 3, 6. 3, 6 also cannot be considered. Then you have 3, 5. 3, 5 also cannot be considered. Then you have 6, 7. 6, 7 is this. 6, 7 also cannot be considered. Then you have 3, 7. 3, 7 also cannot be considered. And then you have 8, 9. 8, 9 is this. Let's check this one. 8, 9 can be taken because 8, 9 is not forming a circle. So 1, 3, 2, 6, 6, 8, 2, 5, 3, 6, 3, 5, 3, 7 and 6, 7 cannot be included in the tree. This also will form a circle in the MST. So we include 8, 9 in tree which does not form a circle. Now all the nodes, all the vertices of the networks are connected using the tree arcs. So since all the vertices are connected with a total of 8 edges, remember we had seen over here a total number of edges in a minimal spanning tree should be equal to 1 less the total number of vertices, which is 8 in this case. So we have 8 edges and all the vertices are connected, and hence the minimal spanning tree is found. The total span on this particular minimal spanning tree is 32. And this is how we find out the minimal spanning tree to a given network. See over here, if you are trying to supply water from any of these points, suppose you supply water from here, the water will be reached to all the vertices of the network. Or if you supply electricity from any of the point, suppose you supply the electric current from here, all the vertices will receive the current. Similarly, optical fiber, you supply the internet connection from here, and then all the vertices will be receiving the connections. And this is the advantage of knowing the minimal spanning tree, and the algorithm that we used for finding out this minimal spanning tree was called Kruskal algorithm. And these are the steps of the algorithm. Hope you have understood, and this is how we find out the minimal spanning tree to any given network. Thank you very much. Keep watching.